Good afternoon everyone. Myself Professor Swapnil S. Tudke of SND COE and Research Center Evla, working as Assistant Professor at Electrical Department. Now we will discuss the subject, that is Advanced Microcontroller and Embedded System, in which we discuss the topic of Unit 4, that is Interrupt Structure and its Programming, in which we discuss the topic of interfacing of LCD 16:2 in 4-bit mode. Here first we see the 8051 microcontroller interrupts. The 8051 controller has 6 hardware interrupts, of which 5 are available to the programmer. These are as follows. First one is reset interrupt. This is also known as power on reset POR. When the reset interrupt is received, the controller restarts executing code from 40H location, that is 4 times 0H location. This is an interrupt which is not available to, or better to say, need not be available to the programmer. Second one, timer interrupts. Each timer is associated with a timer interrupt. A timer interrupt notifies the microcontroller that the corresponding timer has finished counting. Then the third interrupt is the external interrupt. There are two external interrupts, AX0 and AX1, to serve external devices. Both these interrupts are active low. In 8089 C51, P3.2 int 0 and P3.3 int 1 pins are available for external interrupts 0 and 1 respectively. An external interrupt notifies the microcontroller that an external device needs its service. Then fourth one is serial interrupt. This interrupt is used for serial communication. When enabled, it notifies the controller whether a byte has been received or transmitted. Then how is an interrupt service? Every interrupt is assigned a fixed memory area inside the processor or controller. The interrupt vector table IVT holds the starting address of the memory area assigned to it corresponding to every interrupt. When an interrupt is received, the controller stops after executing the current instruction. It transforms the content of program counter into stack. It also stores the current status of the interrupts internally but not on stack. After this, it jumps to the memory location specified by interrupt vector table, that is IVT. After that, the code written on that memory area gets executed. This code is known as the interrupt service routine ISR or interrupt handler. The ISR is a code written by the programmer to handle or service the interrupt. Programming of timer interrupts. The timer interrupts IT0 and IT1 are related to timers 0 and 1 respectively. Please refer 8051 timers for details on timer registers and modes. The interrupt programming for timers involves following steps. First one is configure T-mode register to select timer and its mode. Second one is load initial values in THX and TLX for mode 0 and 1 or in THX only for mode 2. Third one is enable timer interrupt by configuring bits of IE register. Fourth one is start timer by setting timer run bit TRX. Fifth one is write subroutine for timer interrupt. The interrupt number is 1 for timer 0 and 3 for timer 1. Note that it is not required to clear timer flag TFX. Sixth one is to stop the timer, clear TRX in the end of subroutine. Otherwise, it will restart from 4 times 0H code in case of modes 0 or 1 and from initial values in case of mode 2. In seventh one, if the timer has to run again and again, it is required to reload initial values within the routine itself in case of mode 0 and 1. Otherwise, after one cycle timer will start counting from 4 times 0 H location. Thank you. So we discuss here the timer interrupt programming in this lecture in detail, not the LCD interfacing.